Please welcome to the stage Managing Director of Financial Services at AWS, Scott Mullins.
Folks, good afternoon and welcome to the 2025 Innovation Talk for the financial services industry here at AWS reInvent 2025. For those of you who don't know me, I am Scott Mullins, and it's my privilege to lead the financial services business here at AWS. I've been very fortunate to be a part of many of those watershed moments that you saw highlighted in the video that we just shared with you. And that was like a 1-minute kind of roller coaster ride through the last 13 years of what we've been doing. And then the very first thing that you saw was one of the only and first sessions for financial services at the very first reInvent in 2012. And while some of the things about reInvent have changed over the years, from the number of attendees that we have to the advancements in both AWS services and our customers' use cases, what hasn't changed is our shared willingness to continue to push past what is currently thought to be possible. For more than a decade now, we've been moving the industry forward together, at times with deliberate and important incremental steps, and at others with leaps and bounds, but always with the conviction that we can make it better. And as a result, today, AWS is the home to the mission-critical systems that power the global financial services industry. And together, we're actively evolving how financial consumers are served. Evolution happens quickly in our industry because financial institutions have chosen to change instead of just waiting for change to happen to them. One reason that we now stand on the threshold of a new frontier today, where agents won't only chat with us, but act on our behalf, is that financial institutions have been preparing for this moment for years. They've moved their data to AWS and set up processes and guardrails that would enable them to securely and confidently take advantage of machine learning and generative AI. And in doing so, financial institutions were ready to embrace the opportunity to tackle long-standing challenges and transform the way they operate with agentic capabilities. This week at reInvent, we've heard from many financial services customers how agents are helping them rethink their core businesses and become more productive, secure, and efficient. Moody shared how the company deployed multi-agent systems to process large data sets and conduct specialized research and analysis. Ripple shared how it transformed security operations by building a multi-agent system that analyzes massive log volumes and enables guided investigations. And Commonwealth Bank of Australia shared how it's using agents to automatically analyze legacy code, perform security assessments, and handle network flow implementation. And that's just a sample of the industry-focused breakout sessions our customers are delivering just this week, and a fraction of the agentic AI use cases we're tracking across the industry today. The common thread here is that financial institutions are entrusting agents with increasingly more critical responsibilities and allowing them to interact directly with their customers, handle sensitive data, and execute complex tasks. But even more powerful change is on the horizon. Autonomous AI systems, not just goal-based agents, are poised to transform the way that organizations build financial services and the way that we all consume this. So what will this look like? Well, across the next frontier, agentic systems will more and more become a part of our daily lives. Let's see how this looks. So let's say you've been offered a job that would require you to move, and maybe you need to buy a new house. Because my personal financial agent knows me, it can look for properties that align to my taste, needs, and financial resources. You can see I have a particular taste in the style of home. Imagine that it finds a property that looks really great for me. But before I move forward, my agent actually takes a deeper dive into the disclosure statement for the house I'm interested in and finds out that the basement flooded a few years ago. That's actually happened to the home I bought recently. My agent then accesses a weather database on its own to find out that changing weather patterns have put this home in a risky flood zone going forward. This is the type of action that agents can proactively take on our behalf today to save us time and money, but also to minimize risk. Agents will also do things like analyze your financial situation in real time and evaluate your current holdings to see if you're properly balanced and shifts funds accordingly to make sure that I can actually afford that home. Your agent will make it easier for you to make informed decisions when it comes to evaluating which equities I might want to transfer around or sell to minimize capital gains taxes, or how much money you should set aside for perhaps your kid's college fund based on your current earnings and savings. They can independently perform research to make a recommendation and then present enrollment forms. So agentic systems will make really make life easier for consumers like you and me, but they'll also make life easier for providers as well. Let's say your agent thinks you may want to purchase some life insurance based on your recent interactions. Well, insurance underwriting is a difficult and time-consuming process because it requires manual data collection and extensive internal and external research and analysis. Agents are already streamlining this process by automatically extracting data from submission documents. But in the near future, autonomous AI systems will go a step further by performing risk assessments and then enabling agents to negotiate prices with other agents. New capabilities have put this vision of the future within reach. The length of tasks that agents can accomplish has increased from seconds to hours, while costs have decreased from dollars and cents, and we heard from Matt Garman on this on Tuesday. But for this autonomous agent-to-agent future to work at scale, we'll need more than just technical capabilities. We'll need trust. Organizations will need to trust that autonomous systems can operate securely, comply with regulations, and protect sensitive customer data. And as an industry, we're going to need to align on standards and protocols that facilitate and incentivize trust between companies. The path forward to this trust-based future starts with Amazon Bedrock. And as you heard from Matt Garman in his keynote yesterday, we continue to add new foundation models, 18 new foundation models, to the broad selection we already provide through Bedrock, so that you have the freedom to choose the right model for the right job. Matt also introduced and announced 2 new features within Bedrock Agent Core called Policy and Evaluations, 2 new capabilities to help you deploy and scale agentic AI systems securely without operational headaches. And I'm really excited about those 2 features in the financial services industry. Today, we're here to learn how financial institutions are using Amazon Bedrock and other AWS services to build the future of the industry. And we're fortunate to have 2 customers joining us to share their experience and guidance. First, we're going to hear from Axel Schell, the CTO of Allianz Technology, who will share how one of the world's largest insurance companies has built a framework for bringing AI-powered solutions to production securely, consistently, and quickly. And then we're going to hear from Eric Rappel, who is head of engineering of Coinbase's developer platform. He'll share how Coinbase is making the vision of agentic commerce a reality through its X402 protocol. So now, please join me in welcoming Axel from Allianz to the stage.
Thank you, Scott. So pleasure to be here. And what we want to do is we want to talk about moving the frontier to the next level. One of the questions I get regularly asked is, how will business and our technological environment look like in the next 3, 5, or 8 years? And that's a very difficult question. That's the famous $1 million question. And one of the answers is, and that's maybe something that we can say is, in short, almost everything will change in the future. We will, for sure, shift boundaries and frontiers. Now, let's try to understand why moving frontiers and boundaries is, first of all, very important, but also, secondly, why is this relevant these days? If you look at the current world we're living in, you see, we call it poly-crisis world, where lots of things are happening. Number of meta outages increases, more data breaches, more natural disasters, a lot more deep fake related to AI, but also global terrorism and IT attacks increase over time. So you see, we live in this poly-crisis world that makes the environment quite difficult. And when we look into this global perma-crisis, you see what's going to happen. First of all, we have a very fragile geopolitical situation. Climate change is coming and approaching, and that's relevant for human and also for our economy. And you see lots of demographic change that influences all of our lives. And last but not least, there's something called AI and digitalization, which of course adds on top of all those elements. And I think one thing that we can say is that this results in an environment of change and lots of uncertainty. Now, the key question is, if we live in this perma-crisis, poly-crisis world, the key question is IT these days a catalyst of change? So is it actually something that is the core of disruption and makes the disruption even faster? Or is it an instrument of resilience And that means if you're ahead of the curve and you're more or less leading the pack, you're early enough, then this can be an instrument to create resilience. So does it disrupt or does it create resilience? And what is absolutely clear is that if we want to look at the future and to advance the boundaries and to move the frontiers to the next level, one thing is very clear. We have to manage our future, the future of IT and the future of those companies. Therefore, whatever world you live in, we have to actively play a role in managing this future. Now, the question is, how do we do this? So, very quick introduction about Allianz, that you understand a bit of the background. We're roughly 150,000 employees. We operate in 74 countries, and we are the leading financial services insurance brand, and we have roughly 2,200 billion assets under management. That's the responsibilities that customers gave us. We are a 135-year-old company. And the key question is now, if we look at the IT, the disruption, the resilience, what's going to come there, one of the key questions we ask ourselves on a daily basis is, how do many people shop around for insurance today, and how will they do that in the future? If we look at how they do it today, there are lots of aggregators. You go on an aggregator page, you get a couple of comparisons for an insurance product, and then you maybe decide for which one you want to go to. But the question is now, is AI maybe the new aggregator? And I have an example, and let's start from the end customer, which is here, my cat. So what we do now is we buy a pet insurance for my cat in a modern way. All I do is I upload this animal passport with a couple of key information on, which is nothing else than the name of the cat, when was it born, the gender. So a couple of key information, that's everything that I use. And what I do now is I use a single prompt to buy an insurance product. The single prompt is order for my cat a pet insurance product with a best price to performance perspective, proceed to the checkout, do as less as possible interactions. And what you see now is here an agent, and then I think you're very well aware of the agentic browsers that are out there, the Comets of the world, the Atlases of the world. We just use here one example. Go through the process and starts to look at various websites, tries the comparison. The whole thing takes roughly 4 to 5 minutes. I will not go through all of the details now, of course. And it ends with buying a cat insurance or a pet insurance for my cat. So I have already 3 pet insurances now, because once I tried it the first time, the second time I recorded the video, and the third time when I did a live demo. So I will not do a live demo today. 3 insurances is already enough. By the way, from different brands, which is also an interesting experience. Now, what you saw here is agentic browsing, here specifically for financial services insurance products. What you see here is that we move away from, in the old web days, a grammar-constrained decoding to now very reliable, or at least much more reliable tool calls. We move away from browser APIs that just can do read, modify, or click, or navigate, to navigation in real web UIs. They're completely flexible. The agent doesn't care how the website looked like. If they did a change on the design the day before, the navigation now is different. And those agents have lots of capabilities. They plan, act, observe, now correct. They do multiple times. There's reasoning behind, so they're quite good. That gives a lot more capabilities. You have now full web workflows, not only for a web page, but also internally for some of your web applications maybe. And we can parse and combine data from various sources. And of course, it's also great if you just open a new tab, you can navigate across multiple systems. Now, what it means, there is a universal automation layer now existing with agentic browsing capabilities for all kinds of web applications, including legacy applications, even some of them that don't have proper interfaces and don't have APIs. And it replaces also a bit the custom integration with one agentic interface. How great your web design is no longer relevant for the agent. That's not the most important thing. And of course, my productivity increased a lot. I mean, writing the prompt took me 20 seconds, and that's it. I just had to check then if I'm happy with the result, but also productivity is completely different. Now, what does it mean, and why is this relevant now? I think we are very well aware of the world where a user interacts with a website. Now, we live in a world where maybe the user in the future interacts with an agent and asks the agents to do certain activities on the web, procuring, buying products. But is this the world that we think that everything will end up with? I don't think so, because we don't want, as an Allianz Insurance, that thousands of agents crawl our website and click on the buttons. I mean, what you just saw is like a large language model processing pictures and then telling the mouse to move 50 pixels up, 50 pixels down, and click on the next button to see what happens then, take a screenshot, bring it back to the large language model, understanding what's on the screen, giving instructions to the agent. That's not what you want. A lot of compute, a lot of capacity is needed. So what will happen is that we will also have our own agent. The Allianz agent then shows up and says, cool, you're an agent, I'm an agent as well. Let's interact with each other in a completely different way, with lots of protocols. And also payment will be interesting. And Eric later will talk exactly about this kind of agent-to-agent payments, which will be a very interesting journey as well. So agents communicate with each other in a totally different way. Now, that was for us the starting point to understand how our AI journey looks like in the next couple of months. I mean, nobody knows what happens in 2 years. We live in the famous cat and dog world of AI, where years of AI, where time moves so quickly. But we started to work with colleagues from AWS to do some kind of code development and to better understand the basics of agent capabilities. And we selected an area where we started with the team of our risk colleagues. And they spent a lot of time gathering and aggregating information. That took a long time. And what we actually wanted to do is to make the time, there's yay time and nay time. The yay time is stuff they like. The nay time is just data gathering, which they don't like. We wanted to shift the yay and the nay time and move the 20% of their actual work into a much higher productivity level. So we wrote a kind of model-agnostic multi-agent framework that we collaborated on. You see here how the features look like. Amazon Bedrock, we use Claude as large language model. And that kind of model is, first of all, built in a way, or framework is built in a way that it's an open model selection is possible. We have, of course, agents that work, and we heavily rely on MCP. This is how it looks like from an architecture perspective. This is our multi-agent framework architecture. Nothing super fancy. I think you would expect how that looks like. You have an S3 bucket where we store the data. We have our VPC endpoints. We have our GenAI lab agent. This is actually our home for the agent, where the agent lives. And then we use LangGraph and also some Fargate capabilities. We do network address translation over the internet and then process everything and also integrate. Now, why is this important again? I like this slide a lot because it shows the journey where we come from. You remember all of the times where we're heavily discussing that monoliths are not what we want. We have to move to microservices. So more developer efficiency, very simplified operations and tech stack. So this is what we thought. But there were some downsides. Duplication of effort, inconsistent standard, increased complexity, complex governance. I think you're very well aware of the challenges of microservices. The second thing is on cloud. Everybody said we have to move away from on-prem and have to move to cloud. And there were many advantages. I just put one here, cost reduction, improved resilience, many benefits from cloud. But it also comes with downsides. You have a technical login through maybe lift and shift. You have maybe increased parallel run cost, complex transition, and so on and so forth. Just a couple of downsides. And what I want to compare the agentic world of the future is exactly with those problems. We will love agents. They will do unbelievable cool things. But they will come with a lot of downsides. And we should be aware of those already now. Because if we don't think about those, if we don't have a proper governance a proper structure how to work with agents, we will run into many, many problems in the future. Now it's still manageable because it's early stage, but we have to think now about this. What I foresee is something like, if you look at what many companies do, they start with these siloed POCs. There's a meeting preparing assistant, co-pilot, supporting assistant, legacy modernization, HR bot, source code management, public cloud as underlying applications. So many of those agents, there is very low reusability of those agents across the verticals, and they are very tightly linked to use cases. And incremental value realization is what happens. So this is the world of the many POCs. It's nice, the use case is great, but how do you actually really leverage the power of bringing things together? Is this something that is scalable? And we should never forget one key sentence, which is, you can scale everything, but you cannot scale complexity. You cannot scale complexity. And there's high risk on the left-hand side to run into very complex environments. Now, what you need is something maybe even more on the right, where we call it Gen AI mesh, where you have certain agent discovery capabilities, registry and orchestration capabilities, where you try to reuse agents across any of those use cases. You need a kind of a flexible plug-and-play system, no lock-ins, and that will lead to at scale value realization, not only incremental value realization, but really at scale value realization. So keep that in mind. When you see your agents growing, you need to find a way how to move into this Gen AI mesh and move away from vertical pilots. Now, how do we do that? This is our current thinking, and I'm not saying that this is the best what you can do, but this is how we try to solve the problem, and this is why I think this is relevant. We started to define certain levels for agents. We have, first of all, our system of records, like databases, policy assurance, case database, solution database, whatever. And then on top, we stack more or less some agentic layers. We have, first of all, utility agents on level 3 that can be highly reused for documents, for video imaging, for processing, for voice, for email. On top, we have so-called business agents on layer 2 that are more business-specific. They deal with notifications, with solutions, with case management, with policy assurance. And then we have level 1 planner agents. They orchestrate the workflow. And all of that is then linked into our customer journeys. And with this kind of architecture and reference structure, we're able to utilize agents in a way that the reusability is much higher, that creates less complexity, that leads to more harmonization, and is a lot easier to scale. The way how that works is, we call it framework, an agentic architecture framework with more or less 4 components. There's first of all the core stack, where we have front-end orchestration and also AI workflow tooling. You see here some of the technologies that we leverage. We have our DevOps tools, which is mainly around automation, but also the continuous deployment processes. And then, of course, some AI models. Flexibility needs to be built into the architecture. And you need some foundational service layers as well, where you, for example, do all of the container orchestration, where you have also the possibility to work with API management. You have the full stack observability. And the way how this looks like is something like this. What you see here is a bit an agent control plane that we have developed that is kind of a marketplace internally. Because as I said, observability, reusability only works when you can also discover those. And what you more or less need is something like an organized marketplace, a space where you can collect, showcase, and engage those agents. You need to administer them properly, and that includes, of course, config. You need to monitor them, the consumption. There will be, for sure, after the FinOps world, also something like an agentic ops, where you just need to reduce costs because the LLM models will at a certain point become quite expensive. And of course, you also need some kind of agentic prompt playground where you can experiment with new agentic applications. And if we do one more level deep dive into this, I have here an example, which is a claim handler agent. These are the kind of agents you would find on the marketplace in the various L1, L2, L3 levels, which you can draw from. And you have here a couple of capabilities. You can either use MCP to connect or also connect with a REST endpoint. You see what tools are available that are coming with the claims handler agent. You see, for example, also the possibility to run a test case. You enter a test case number, you execute the tool, you see the results so that you can play around with it and understand what the agent can do. And then you see also on the right-hand side, the very important step, all of the traces and the traceability, what the agent is actually doing. Because in a regulated industry, you have to make sure that you know what the agent also did. So you see, for example, the reasoning behind, you see all of the steps properly documented. You see when the execution is complete, you see timestamps, you see audit logs, all of that on the right-hand side. And this is the kind of setup that we use in order to join this new agentic world. The new agentic world, from my point of view, will grow extremely fast. I mean, 2 years ago, we didn't discuss agents. Last year, agents were a big thing. This year, I have a bit the feeling that people now understand how powerful those are and what is going to happen in the future. And we have to prepare ourselves to be ready for many, many agents that we need to manage, orchestrate, and also as an IT govern properly. Now, let's imagine and let's leverage the agentic capabilities for a second. Let's imagine there's a blackout, no power. And what happens is your fridge also has no power, and everything that is in the fridge is no longer eatable after a certain amount of time. This is one use case that we have implemented where we use agents to do claims processing and also settlements. We have a couple of agents. First of all, we have a planner agent that initiates and coordinates the workflow. This is, as I said, on level 1, the one that does that. We have a cyber agent that works on the security part, a cover agent that actually verifies if the insurance customer is actually covered by his policy. There's a weather agent that actually looks, was there really a power outage happening? Was there, I don't know, a thunderstorm or something like that? There's a fraud agent who looks into all of the fraud capabilities. There's the payout agent in the end who does then the payout to the customer. And there is an audit agent. And what we could use, we could reduce our processing time by 80%, something that took more or less around 100 days. And now we have 7 agents in a workflow. And it's a very powerful tool that many of our customers like. And this is how it looks like. So what happens is you start your mobile app, you get welcomed by the agent, and it says, "Hi, my fridge lost power during the storm, and all my food has gone bad. I'm really sorry to hear. First of all, it wants to understand who are you. So basically, you provide your email address, and then the next step is it wants to understand the full name, date of birth, home address. Understood. The address has been verified, and then it continues with, when did this happen? Please send me a picture of the fridge, and then the agent does all of that. And in the background, this is what you see on the right-hand side. What the customer cannot see is all of the various agents that are starting now. The coverage agents, the fraud agent is looking into this. And then, of course, the weather agent will check if there is a weather incident. The payment agent does the stuff, and so on and so forth. And you see then that in the end, it ends up with all of the audit trails and the logs, why we took a certain decision, how much the payout is, so that we are covered from a regulatory perspective. So I think that's a good example. That is one use case, how you can work with agents. But now imagine we run thousands of those use cases, and we have to make sure that we have all of this under control. Therefore, better plan now for what's going to come in the next 1 to 2 years. Thank you.
So Axel, thank you for sharing how you've built a platform for systemically and securely deploying agents to reinvent insurance. Now, a theme we've heard a lot this week is trust. We need to be able to trust agents to do what we need them to do and to act responsibly on our behalf. And as we move further into our future, we need to trust agents to work responsibly with one another. But that trust isn't going to magically manifest itself. We're going to need to create and to incentivize it. Which brings me to our next speaker, Eric Reppel from Coinbase. Eric is going to share with us how Coinbase is taking pragmatic, tangible actions to build the trust that will form the foundation of the agentic future of commerce. So please join me in welcoming Eric to the stage. So sweet. So sweet.
Thanks so much, Scott. I'm super excited to be here. I'm Eric. I lead engineering for Coinbase Developer Platform. We're kind of like the AWS to what AWS is to Amazon, CDP is to Coinbase. We've taken the tools and capabilities that Coinbase has built over the years around blockchain infrastructure, custody, payments, and we're now externalizing those services and making them available to other customers who want to build on top of our infrastructure, which we, of course, build largely on top of AWS. So I'm going to talk a bit about a vision for the future of payments. But where I want to start is I want to start with the internet. So the internet was really designed for humans. We, as humans, use the internet all day, every day, and we kind of use it through these devices that we have. And a lot of the standards that we have to use the internet are really built with this concept of human in the loop, where a human is driving a computer that is then interacting with other computers. And in Web 1.0, back in the 80s, we got really robust standards for sharing information. The internet really started in academia with researchers wanting to share papers and content and their work with other people around the globe. And that was great. We got HTML, we got HTTP, we got the World Wide Web client, which we now call a browser, much better name in my opinion. And then we moved on. We went to Web 2. In the 90s, we got Web 2, and we kind of got the explosion of utility that we see today. And that was really powered by standards like JavaScript, AJAX, JSON, which let you write. The web is no longer read, now it's read and write. And really, my point here is that the internet evolves through standards. Standards are conventions that we all agree on. There's no controversy involved that you're going to write your website in HTML. And the power of that is that any browser that you use works with any website that you visit without there having to be some kind of bespoke agreement that goes on. Every company on the planet writes HTML and uses HTTP, and that openness creates a positive sum feedback loop where things that were possible, things that aren't possible if you have to negotiate one-on-one are now possible. And so all these formats do very specific things, and they've largely answered a bunch of these questions, like how do I give you information? What should that information look like? But we've never actually managed to solve the problem of how do I give you value? There's actually no standards, no open standards tied to the internet for payments. And there's this Mark Andreessen quote, I think the original sin was that we couldn't actually build economics, which is to say money, at the core of the internet. And we kind of never resolved this. This is a quest Mark Andreessen went on in the 80s and 90s to try to make payments native to the internet. Not something that's done kind of in the requests that happen, but payments that can accompany the requests as part of the core backbone of the internet. But eventually we got HTTPS, we got encryption, we became comfortable sharing credit card or bank details in internet requests, and consumer behavior changed. They became comfortable typing in a credit card and hitting send and sending their information to a company to process offline. And we mostly forgot about this idea of internet native payments. But you see remnants of it. You see artifacts in the history of engineering that's happened over the years that indicate to this forgotten past. And one of them is this 402 payment required status code. For those of you in the audience who aren't familiar, HTTP status codes exist to convey a programmatic message of what went wrong, what happened, or what went right. What happened when your client made a request to my server? If I send you a 200, everything went perfect. 200 just means okay. Probably everyone in this room has seen a 404, not found. 402 was encapsulated at the same time 404 and 200 were, and this is the entire definition of the standard. 402, payment required status code is reserved for future use. And so we never actually got around to using the status code. It's kind of used occasionally in payment workflows, but there's no standard that works alongside 402 to have a consistent open payment experience like you can have where you visit any website, you download their HTML, and you can now view the content of the website. Each API that you need to, for payments that you need to integrate is slightly different, have slightly different conventions. It's not a do one integration, you get payments everywhere. And payments are the hardest part of the internet. But they're the most important unlock in the last 25 years. Checkout is a very human-centric experience. You see, everyone in this room has probably filled out a form that looks similar to this, where you put in a credit card number and an expiration and a security code and an address, and repeat UX is quite good. Typically, companies will store the credit card, but first-time UX, usually you have to go through this step. And while visually these may look very similar between different services or different websites, technically they're very different. They may have nothing in common between different websites you visit. Visually, it's similar, but what the machine sees, what a computer sees, could be entirely different. It's also complicated. This form has 14 fields. We've gotten used to it as humans. It's an okay experience. I'm being a little spicy on this slide and saying it's a bad experience for humans, but it's okay. It's worse for agents. Agents are really probabilistic systems, which means that they may not do the same thing every single time. I'm sure all of us have experienced this using chat interfaces or LLMs, where you ask your LLM the same question. First time it gives you a great answer. Second time the answer is a little different. Maybe it doesn't quite hit the same points. And what that means is if you have to probabilistically accomplish 14 tasks in a row, the probability of completing the entire task is now dependent on the entire set of tasks being complete. And so if you have a 85% probability of completing each field, you're now timesing 0.85 times 0.85 times 0.85, and you can get flaky really quickly. And agents also have to be really good for you to trust them with your credit card. I think all of us in this room would be a little hesitant to give unfettered access to their credit to an AI agent at this point in the cycle. And so AI really forces us to reevaluate internet-native payments, payments that adhere to a standard and that works everywhere, similarly to how HTML works anywhere the internet works. And I think at Coinbase, we have this broad thesis that stablecoins are a really good use case for AI agents and work extremely well for the agentic commerce scenarios. And look at the robot. He goes from sad, and then you give him a stablecoin, he gets very happy. And what I'll talk you through today is how we've been developing an open standard for payments, internet-native payments, and how it can leverage stablecoin and crypto. It'll work with fiat as well over time. But how stablecoins have really uniquely enabled some things in agentic commerce that I think are very difficult to replicate. So what is a stablecoin? A stablecoin, for those of you who may not be familiar, is a blockchain token that is backed one-to-one, typically, by reserve dollars. So the stablecoin Coinbase is known for is USDC. USDC has audited reserves in treasuries and liquid dollars and bank accounts, backing each digital dollar that exists. And what that unlocks is, because blockchains have gotten really good over the last 5 years, you have 24/7 availability. You can settle transactions in seconds. Not T+2 now means not T+2 days, but T+2 seconds. And the fees are incredibly low. The blockchain level cost to send any amount of money, whether it's a cent or $1 million, typically on a modern blockchain like Base is about 1/10 of a cent. This is true of many blockchains. Base is, of course, a great blockchain, but Solana, Sui, Aptos, many blockchains have this incredibly quick to transact, incredibly cheap to transact property. And so let's get to the meat of this. An open standard for internet native payments. This is where I introduce X402. So X402 is an extension of the 402 status code. We want to leverage the existing infrastructure of the internet. What is it? It's an open standard for internet native payments founded at Coinbase. It's soon to be moved into an independent foundation. So the governance of the standard is not just done by Coinbase, but it's done by anyone who wants to participate and invest in this idea of an open standard. But really, X402 is a bridge. Payments kind of exist on one side of the water. The internet kind of exists on another. X402 aims to build a bridge so that payments on the internet feel native and we can move value in a similar way to how we move data. And X402 kind of exists in what I'd call the agentic standards stack, where you're starting to see things like MCP that standardize how tools are defined and how tools are used. X402 handles payment. A2A standardizes how agents communicate with each other, and you're starting to see more experimental standards like EIP 8004 for agentic reputation and discovery. And there'll be more to come. Since I've made this slide, ACP started to emerge. You're starting to see AP2. All of these standards, I think, similarly to how HTML and CSS and JavaScript and HTTP are the standards we needed to make the web really sing. You're going to see the composition of these standards work together to really unlock the agentic age. So how's it going? Well, in the last 30 days, X402 has done over 70 million transactions using real stablecoins and real dollars. The GitHub is incredibly popular. It's had over 4,000 people star the GitHub. There's been almost 100 contributors, and there's been over $30 million of volume. I believe it's actually about 38. This is slightly outdated. And there's been over 250,000 people who have bought a good using X402 or a service using X402. And commonly that'll be data, or that'll be access to information, or API use is a common use case. Anytime you have a digital native good, X402 works incredibly well because it natively integrates into your infrastructure, natively integrates into your web servers, and allows you to include payment directly in the exchange of data that is already happening. So what does this enable? So what I've done here is I've given my LLM access to 2 X402 tools, and I've asked it to do some research for me. I've asked it to research X402. How has X402 usage and adoption been going? And you'll notice it does a web search to try to understand the X402 protocol, and it gains information that's available on the public internet. And then it searches, it uses the first tool to search for paid resources that may have information about trends on social media. And then it will actually just go and pay 5 cents to access that data. I don't need to go and create an API key or integrate an MCP. That's an API that exists, and it can pay directly for that access to content. And what you see here is I can create an experience where this agent has dedicated siloed funds that has about 56 cents, and I can create rules about what that agent can do and how it can spend. And these isolated funds, there's no way for the agent to spend more than the funds I've given it. I can say, hey, you're only allowed to spend 25 cents per session or $1 per day. And it becomes trivially easy to codify these kinds of rules into the experiences that you build because these dollars are digitally native. It really is money that is truly digital versus kind of systems that you need to interact with via APIs that are not money moving from account to account. And the great thing about this is because this is open standards, anyone in this room with a good engineering team can build exactly this product that we have. And any service that's available that accepts X402 payments can be paid for in this server using this client, using this MCP. And this creates what I call dynamic agents, where right now if you have an agent, you kind of need to integrate one tool at a time. And your agent kind of operates in a box that you define for it. And the capabilities that it have are really set by you. And if it doesn't have a capability to accomplish something or to use a tool that may be useful for the task it's trying to perform, it's just not going to be able to do that. But if now you open the aperture and you have an open standard where anything that accepts these payments can happen without a pre-existing negotiation, your agent can find anything available that accepts these kind of payments and just pay for the services that it uses. And because stablecoins are a tenth of a cent to transfer, it means that paying a cent or 5 cents or $1 becomes truly possible. If you might have noticed on the slide a couple slides back, there's been about 70 million transactions, about $38 million in volume. That's less than $1 on average per transaction, which is actually quite the feat. And this works for payments from a cent to $1 million. The fees are the same, the costs are the same, there's no percentage-based fees. In fact, X402 doesn't have any fees in it at all as a standard. There might be costs associated with doing the underlying payment network's transfer, but there's zero fees at all at the standard level of X402. So why now? Why now? Well, AI is the obvious answer, but I think there's some more subtle ones. I think stablecoins have product market fit and are here to stay. We're getting more and more clarity on the regulatory and compliance side of stablecoins, and more countries are investing and looking into what stablecoins will look like and how the benefits of stablecoins can serve their constituents. The UX for blockchains has gotten really good, really good, and it gets better every single day. I think you can now create experiences that leverage blockchain technologies that as a human, as a user, you don't even realize it uses crypto. But you get all the benefits, 24/7, low cost, instant settlement. And now, as I alluded to at the beginning, AI agents are really going to force non-human-in-the-loop payments to exist, where the human is not always driving the use of the computer. The agent is now driving the use of the computer. And AI breaks the fundamental economic arrangement of the internet in many ways. So, if you think about the internet, roughly the consumer web monetizes in this pattern. I'm hand-waving a little bit, but typically as a user, you'll see content and ads served to you by a website. In the background, a merchant has done an ad placement and paid that website to show you that ad. And then at some probabilistic rate, you will convert, you'll see the ad, and you'll buy a product from the merchant. Except the issue is with AI, you end up not seeing the ad. You may have noticed, but when an LLM scrapes a website, it largely focuses on the content, not the advertisements. And so if you're not seeing the ad, how does the payment occur? I think this is going to be a big problem, and we've seen a lot of this in big labs going and scraping data, and the publishers not being able to capture any of the value that they're creating. And what X402 does is you can now directly pay for the content within the same request that happens. It's a much more native to the internet way of moving value. Your AI can go to a website and say, hey, the website can notice it's an AI and say, hey, I want 25 cents for you to access this content. This is a really valuable blog about the best restaurants in Vegas to eat at. If you're going to consume this, I want 25 cents. That may be a fair exchange, right? And so how does this work? So X402 exists in this flow between an agent, a server, what we call a facilitator, and when you're using stablecoins, a blockchain. And the facilitator really exists to abstract away the complexities of building in crypto and make it feel like just building in the web. You can integrate X402 into most languages and frameworks in as little as one line of code. And so given that flow, you can do things like leverage Amazon Bedrock or other tools that fill these open standards to build agentic discovery and agentic payment. And AWS provides great primitives via Bedrock and Lambda and EC2 and the full stack, both the host servers that monetize via X402 and to build agents that can pay with X402. And if you're using stablecoins, you likely need to have a wallet. CDP offers best-in-class wallets that are great and very well optimized to work with agents and to perform operations with stablecoins. The demo video that I showed you is built on top of our wallet stack. We like to eat our own dog food. And our wallet stack is built on top of AWS Nitro and the scaling and KMS systems that Amazon offers. And so what does it look to actually bring these things together? If you're using Bedrock, You can use Coinbase's complementary agent construction kit called Agent Kit, which gives your agent a wallet. You can connect the wallet. You can tell Bedrock about these tools that exist, the tools for discovery and payment that I mentioned in that demo. And then in maybe like 10 lines of code, you have an agent that can buy anything on the internet that supports X402. And so one-time integration costs forever the benefit of open access. So what's the upside here? Well, one, we unlock the monetization of content. We unlock pay-per-use APIs. We unlock micropayments, and we have money now that is natively digital and exists as a first-class citizen of the internet. But really, I think the value is we get more useful AI. If your AI has more capabilities, it can do more things for you. If we don't have these open standards for transferring value, we're going to end up with a walled garden, where each platform, each vendor, has kind of a competing standard that isn't interoperable, where if you're using an agent from one company, it can't speak to an agent from another company. If you're using an agent that can only pay with one company's standard, it can't transfer value to another company's standard, and you end up with the fragmentation of the open internet. And so my belief is that in order to keep the internet alive and to keep much of the web free, we need to create these open standards that make that actually possible in the agentic age. So what's next? Well, for Coinbase, our mission is to increase economic freedom in the world. We think if money can move globally 24/7 with no access, no limit to participation, you'll get a better global financial system. And so if you want to learn more, you can go to x402.org. You can check out the open source repo. All the code for X402, as long as the standards are fully open source and licensed under Apache 2.0. And then if you want to learn more about my day job and Coinbase Developer Platform, go to cdp.coinbase.com. Thank you so much.
Great job.
Thank you.
Eric, thank you so much for sharing with us what you're doing at Coinbase. There's a critical point that both Eric and Axel made in their presentations today that I want to reiterate as we close. To realize their potential, new technologies require new ways of thinking. We can't build tomorrow's systems and applications on yesterday's technology, nor can we build them on yesterday's dogma. We have the opportunity to open our minds to the fact that we are going to build and consume financial services in a dramatically different way. And if we're willing to lean into change, our financial lives will feature more choice, greater access to capital and opportunity, and better protection from risks to our businesses, our families, and our prosperity as a society. So thank you to Axel and Eric for sharing their perspectives today. And thank you all for joining us on this passage to the next frontier in financial services. Have a great reInvent.